Hi students, in this video we will learn real numbers, paper 1, first chapter. What are real numbers? The set of rational numbers and irrational numbers are called real numbers. Real numbers are denoted by capital R, set of rational numbers Q and irrational numbers Q dash. Rational numbers contains 3 set of numbers, natural numbers, whole numbers and integers. What are natural numbers? The counting numbers are called natural numbers. What are whole numbers? The natural numbers along with 0 are called whole numbers. What are integers? The positive numbers, negative numbers along with 0 are called integers. So these 3 set of numbers includes in rational numbers. What is the form of rational number? A number which can be expressed in the form of P by Q, where PQ are any integers, where PQ belongs to integer and the denominator should not be 0, Q not equal to 0. What are irrational numbers? The numbers which cannot be expressed in the form of P by Q, where PQ are integers and Q not equal to 0 are called irrational numbers. For example, irrational numbers root 2, root 3, the numbers which are having no perfect square roots are called irrational numbers. The set of these two sets, the union of these two sets Q and Q dash are called real numbers. In this chapter, the first concept is finding HCF by using Euclid's division lemma. Euclid's division lemma. What is Euclid's division lemma? Given positive integers a and b, there exists a unique pair of integers p and q satisfying a is equal to bq plus r, where 0 less than or equal to r less than b. This is condition where a, b are some positive integers. Here q and r also some positive integers which is satisfying a equal to bq plus r, and the remainder must be between 0 and b. This condition is called the Euclid's division lemma. By using Euclid's division lemma, we can find out HCF. What is HCF? Highest common factor. How to find out HCF? Let's take an example. 50 and 70. How to find out HCF? By using this condition. Here, clearly A is greater than B. This is nothing but division lemma. Dividend is equal to divisor into quotient plus remainder. Here, which is divisor? Which is divisor and which is dividend? Dividend is bigger number. So, A is equal to 70 and B is equal to 50. Now, apply this condition. A is equal to BQ plus R. 70 is equal to 50. Check out in 50 table where you will get a product as 70. 51's 50, 52's 100. 2's is more than 70. Therefore, 51's 50. 70 minus 50. Remaining is 20. This is division lemma only. Next, now here the divisor becomes a dividend. We want to continue this process until we will get a remainder as 0. Now 50 becomes dividend. Here remainder becomes divisor. What is remainder here? 20. 20 becomes divisor into, again check out in 20th table where you will get 50. 22's 40. 23 60 more. So we want to take 22's 40. 50 minus 40. Remaining is 20. 22's 40. 50 minus 40. Remainder 10. Again same process. Now 20 becomes a dividend. And this remainder becomes divisor. Again check out in 10th table where you will get 20. 10 2's 20. 20 minus 20, 0. Remainder 0. Now, in which case we got a remainder 0, what is the divisor? Check out divisor. Here the divisor is 10. So this considered as HCF. Finally, where we got a remainder 0, in that condition, what is a divisor? That is considered as HCF of given numbers. Next concept, Fundamental theorem of arithmetic. Fundamental theorem of arithmetic states that every composite number can be expressed as the product of its primes, and prime factorization is unique apart from the order which they occurs. So order we can take differently, but the prime factorization is unique. Let us take an example. Take any one composite number, suppose 48. How to find out prime factors? In previous classes you learned 48 by prime factorization method, division method, 2 twos, 2 fours, 2 ones, 2 twos, 2 six, 2 threes, 3 ones. Now 48 can be expressed as 2 into 2 into 2 into 2 into 3, which can be written as 2 to the power 4 into 3. So every composite number can be expressed as the product of its primes apart from the order of prime factors occur. This prime factorization is unique. Sometimes some members will take this same, like this also they can do. First they can take a third table, 3 ones, 3 six. Next 2 eights, 2 fours, 2 twos, 2 ones. This can be written as 3 into 2 to the power 4. Whatever the order. But this prime factorization is unique. Next concept, every rational number decimal expansion can be terminates or non-terminates. How can you identify the given rational number decimal expansion is terminates or non-terminates? For this purpose, we can take denominator. If denominator contains only prime factors 2 and 5, then this rational number decimal expansion terminates. If denominator contains other than 2 and 5 as factors, then the decimal expansion of the rational number cannot be terminates and repeating. Next concept, if P is a prime number and P divides a square, if P is a prime number, P divides a square, then P divides A also. This is one more concept in this topic. Next concept in this topic is how to prove irrational given number is irrational. For this purpose, small technique we can use. By contradiction method we can prove. We use the contradiction method to prove the given number is irrational or not. Next final concept in this chapter, logarithms. Let a to the power x is equal to n. This is exponential form. For this exponential form, how we can derive logarithm? Log of n to the base a is equal to x. Here how to read? Log n to the base a is equal to x, and here the conditions are n greater than 0, n always must be greater than 0, and a n belongs to real numbers, and here this base also greater than 0 and not equal to 1. A must be greater than 0 and it should not equal to 1. Logarithms base always we can take a maximum as 10. Base we can calculate 10. Next, laws of logarithms. 4 formulas are there. First one is a to the power. First one is a to the power log n to the base a is equal to n. Second one, log xy to the base a is equal to log x to the base a plus log y to the base a. Next, third one, log x by y to the base a is equal to log x to the base a minus log y to the base a. Next, log x to the power m to the base a is equal to m log x to the base a. Next, log a to the base a is equal to 1. Finally, in real numbers, what are the main concepts? The first concept is Euclid's division lemma. By using Euclid's division lemma, finding HCF, we can find out HCF. Next, what is a fundamental theorem of arithmetic? Next, decimal expansion of rational number. And next, proving irrational number, given number is irrational. Finally, applying logarithms. In this chapter, we can discuss about these three. Using Euclid's division lemma, how to find out HCF. by using fundamental theorem of arithmetic, how we can express a given composite number as the product of its prime factors, decimal expansion of rational numbers by checking denominator. If it contains only prime factors 2 and 5, then the decimal expansion of rational number is terminates. Other than 2 and 5, the decimal expansion of rational number is non-terminating, repeating. Next, how to prove irrational number? By using contradiction method, we can prove the given number is irrational. Contradiction method we can use here. Next, laws of logarithms. By applying laws of logarithms, we can find out, we can simplify given problems. We are going to use these topics in real numbers. In next video, we can discuss about exercise 1.1.